Welcome to today's seminar. My name is Beth Mashesky. I'm the Assistant Coordinator for the Sponsored Research Program at ISTC and Seminar Organizer along with Nancy Holm. Today's seminar kicks off with our seminar series this fall with the focus of water quality and water conservation. The schedule for the seminars is on the table outside here at ISTC, or it's also listed on our upcoming ISTC sustainability events on our website. The seminar today will be broadcast, it will be recorded, and it should appear on our website in about a couple weeks. And for future seminars, if you can't make it, those will also be broadcast live and recorded and saved on our website. Also on our website, we have over 140 seminars online over the past 8 years with a wide variety of sustainability topics. I'll ask everyone here to silence their cell phones, and we'll also hold questions until the end. And at that time, we'll take questions here in the audience. I'll bring the microphone around so everyone online can hear those questions. For those online, you can type in your questions anytime with the chat box, and then we'll also answer those at the end. Today, we are pleased to have as our guest Dr. Walt Kelly. Dr. Kelly is the head of the Groundwater Science section at the Illinois State Water Survey and is adjunct professor at the Geography-Geology department at Illinois State University. Dr. Kelly received his bachelor's degree in geology from Duke University, his master's degree in geological sciences from Case Western Reserve University, and his PhD in environmental sciences from the University of Virginia. His interests are in water quality and geochemical research, primarily in groundwater, but also surface water. Research topics include nitrate, arsenic, urban water quality, and geochemical processes in aquifers. Dr. Kelly's seminar today is on state and regional water supply planning in Illinois. Please join me in welcoming Dr. Walt Kelly.
That's good. All right, thank you. Today I'm going to start with a little history lesson about water supply planning in Illinois. It's not on? Okay, so many of you probably remember a former governor who's now in jail, but in 2006 he did something really good. He produced an executive order for the development of state and regional water supply plans, establishing water supply planning in Illinois. And actually was reestablishing because Illinois has been doing this for a long time, but this set up a more formal process and to try to cover the entire state, following a model that actually was developed in Texas, where it divided the state up into different regions and having the different regions work on specific problems or issues in their own particular areas. So what is regional water supply planning? What the basically it's just to ensure that there's an adequate and reliable supply of clean water for every user in the region or state at a reasonable cost. So there's basically 3 questions that are asked. The scientific or the kind of the social questions: how much water will we need? The scientific question: how much water is available? And then kind of some economic questions: what are options for providing additional supplies, reducing demand, and what are the impacts and costs of all this? And there's basically 2 foundations required for us to do this. One is the knowledge of the available water supply, and the second is forecasts and scenarios of future water demand. The Illinois Department of Natural Resources, IDNR, was tasked with providing oversight and funding for this program, and we thank them for providing all the funding that we've got in the last few years. So Illinois has been divided up into 10 water supply planning regions, and they were prioritized based on different demographics and needs and economic things. The top two are considered northeastern Illinois, the Chicagoland, and then east central Illinois, where we are, basically the Muhammad Aquifer area, plus a few other things. The third was the Kaskaskia River Basin. So these three were prioritized as the first ones to be done, and we started on those, and then about a year later, the funding dried up. You may recall there was a recession that happened around then, and a lot of the funding for a lot of work disappeared. However, the surveys, geological and water surveys, continued the scientific work using our paltry GRF resources. But the first three regions were completed, northeastern, east central, and Kaskaskia. And then last year, I restarted the regional planning process with new funds and looking at new regions. As part of water supply planning, DNR sets up these regional water supply planning groups, and these really kind of run the activities in a particular region. So they basically assign the responsibility for developing these water demand scenarios. Originally they were out to 2050, the newer ones are going out to 2060. And the reason that they were picked to lead this effort was they have the best information regarding economic plans, future development and growth in their own particular region. And it was also, part of this was to look at these things from a regional point of view and look at conflicts that might arise in a particular region. So here's the kind of groups that make up these different RWSPGs. That's a picture of some of the people in the east central Illinois. I think that's kind of an old picture. Not everybody is in there anymore, but so, you know, the basic groups that you'd probably think of yourself: agriculture, environment, county governments, electric utilities, various industries, the cities. In areas where there's rivers, navigation can be important, recreation, of course, and then small business, rural water districts, et cetera, et cetera. So these are the people who actually, you know, the kind of economic drivers for a particular region, and so they're tasked with actually coming up with these demand scenarios, understanding what the conflicts are going to be, and then we have to and getting the scientific information from the surveys and using that. They're organized by different groups depending on the region. In the northeastern region, the Chicago Metropolitan Agency for Planning, or CMAP, was in charge. Here in east central Illinois, the Muhammad Aquifer Consortium, which has been in existence for probably 15 or so years now, got the nod. Kaskaskia, there's a Kaskaskia Watershed Association. For the new regions that are being done now, Middle Illinois, the Tri-County Regional Planning Commission, which is based in Peoria, was in charge. Northwestern Illinois, we haven't really gotten that off the ground yet. IDNR has identified an organization called the Black Hawk Hills Regional Council, and they seem amenable to becoming the organizing group for that particular region. Unfortunately, with the new administration coming in, all the funding for these RWSPGs is in limbo. They had grants from IDNR, and then I think sometime in February or March they were told they can't spend any more money on their grants. So they're kind of in limbo right now as to what to be doing. And then the final product that comes out of these RWSPGs is a regional water supply plan. So it needs to contain available and possible future water supplies, the water demand scenarios, what are the deficits that might be faced, what are the conflicts that are potentially going to occur, and what are some possible options for managing water resources to meet the potential future water needs. And this is something that is not just done once and that's it. DNR suggested that these should continue, should be revisited in intervals of less than 10 years. So this is basically kind of an ongoing process, even in the regions that have already been done. Ultimate goal, you can read it right there. This is language from IDNR. So basically, an adequate supply of clean water at reasonable cost for all of Illinois citizens. And here's the reports that these three different RWSPGs have produced. On the left is the East Central Illinois report, which came out in 2009. And the Water 2050 is from Northeastern Illinois. It's a CMAP publication, came out in 2010, and then 2012 Kaskaskia Basin produced their report. So I'm basically here though to talk about what the state scientific surveys are doing as part of water supply planning. And basically we're the scientific experts on this. So we're providing the regional planning groups with the scientific information they need to make these decisions. Develop a website which is up and you can get information off of that. Current water withdrawals, that's an important data point that we collect to understand how much water is being used, evaluate impacts of things like drought, climate change. We attend the meetings of these RWSPCs to provide them with the technical and scientific support. We do a lot of education and outreach as part of that. And comparing future water demand scenarios to the available water supply, that's kind of really the ultimate work that we do. Water quality is listed. It's kind of a fairly minor part of this program. I'm actually a water quality guy, so I'm trying to bump that up a little bit in my tenure, but I'll talk a little bit about that later, some of the stuff that we're doing. But it is important. Water quality, of course, is important in water supply planning. If your water supply is contaminated for some reason, then it's a much less desirable water source. All right, now I'll give you just a little overview of what are the water sources in Illinois. So first of all, we've got this large Great Lake up bordering the Chicago area, Lake Michigan. A bunch of rivers, especially some of the bigger ones, Illinois, Fox, Kankakee, among others. We have a number of reservoirs, 3 federal reservoirs run by the Corps of Engineers, Shelbyville, Carlisle, and Wren. And then there's a bunch of smaller reservoirs that provide water supplies to a number of different municipalities in the state. Some of the bigger ones are in Springfield, Decatur, and Bloomington. And then groundwater. Groundwater, mainly, there's 2 sources. We can divide the geology into the bedrock and then into the shallower sand and gravel or unconsolidated deposits that were left over from the glaciers. Okay, so let's go through a little bit of who uses what kind of water in the state. So here's this is the Northeastern Illinois map showing where the communities, and I think there's something like 300 up here, I can't remember the exact number, where they get their water from. So the light blue area, those are the people in the Lake Michigan diversion allocation region. So you can see Cook County, DuPage County, parts of northern Will County, and eastern Lake County. Once you get away from the lake, then groundwater becomes the dominant source. The yellow represents shallow, and the orange represents deeper units. There's a few places that use surface water away from the lake. Elgin uses Fox River water. Aurora uses a mix of groundwater and Fox River water. Wilmington uses the Kankakee River. So Lake Michigan. So here seems like a boundless supply of water. However, because Chicago reversed the rivers flow back 100 years ago, everybody probably has heard that story before, we transfer almost all the water we use from Lake Michigan out of the watershed, and that's the problem. The rest of the states in the Great Lakes region sued us for that, and in 1967, the Supreme Court ruled against Illinois. This was amended in 1980, and it limits Illinois' diversion of water from Lake Michigan to 3,200 cubic feet per second, and that's based on a 40-year running average. So there's a cap on how much water we can actually take out of Lake Michigan. This is being managed by the Illinois IDNR's Office of Water Resources. So here's the map showing who gets water from Lake Michigan and where it's coming from. So these red triangles are the kind of the intakes from the lake, and then these lines represent kind of distribution systems out to different suburbs and cities. And you can see that they go pretty far away from the lake. And some of these yellow ones represent allocations that were approved by DNR, but the cities haven't used them yet. Down here you can see this is Shorewood, which is very far away from the lake, but not too far from a pipeline up here. They're actually considering going to their Lake Michigan water because of some issues they're having with groundwater up in that region. So here's the Lake Michigan diversion that's been kept track of since 1980. The dashed line is the 3,200 cubic feet per second limit. And you can see for many years we were above that limit, but since about the mid-90s we've started to drop below that limit. And you can look at also just from a point of view of the domestic use, so the water supply for drinking water. Again, you can see quite a drop in use over the years. So there's a few reasons for that. One is they've raised the price. Okay, so that helped reduce the use. They've also replaced a lot of old leaky water mains in Chicago. Actually, some of them over 100 years old. Some of them made of wood, actually, and they leak like crazy. And they're replacing them at a pretty substantial rate. So that's replacing a lot of water that's just lost from the system. And what was the third reason? Oh yeah, conservation. So conservation efforts have really taken off in many parts of the Chicago region, and so that's contributed to this decrease in domestic water. And so if you go back to this slide, you can see that we haven't been going for 40 years yet, so we don't know what the 40-year running average is going to be until 2020. But we're below that level right now, and so there is actually water from Lake Michigan that's available to some of these communities that may be having problems with their water source. And I'm going to talk about that in a little bit. Surface water bodies. You can see if you get away from Lake Michigan, most of them in the southern half of the state. You can see there's Elgin and Aurora up there. There's Bloomington, Peoria. So most of them in the southern half of the state. And so these are rivers and a lot of reservoirs providing water. And you'll notice a kind of a flip from surface water users to groundwater users, and the reason is geology. Okay, so most of the productive aquifers in Illinois are in the northern half of the state, whether we're talking about bedrock aquifers or the unconsolidated sand and gravel aquifers that were put down by the glaciers. There's the Mahama Aquifer right there. You can see in the southern half of the state, really no bedrock aquifers and just some kind of thin alluvial aquifers along some rivers that some towns use, but mainly surface water is used in the southern half of the state, and mainly groundwater, apart from Lake Michigan, in the northern half of the state. So there's a line here. The aquifers, the bedrock aquifers, extend beyond this point. Actually, they underlie the entire state. But the Illinois is a basin, so it's like a bowl. And to get to these units, you have to go deeper and deeper. And as you go deeper and deeper, the water gets more and more saline. And this line here, this kind of arbitrarily drawn line, was based on TDS concentrations. They reach a level where the water is considered non-potable. I mean, you can still pump water out of there. You can still treat it and use it. So it is a source of water, but the quality is not great, and you have to pump it up quite a great distance, 2,000 feet or more in many cases. This shows a cross-section of aquifers, and this is running through the northern part of the state, since that's where the aquifers are. Just showing you some of the geological features. So these blue stippled areas are the main bedrock aquifers. There's the St. Peter and the Ironton-Galesville. There's a humongous Cambrian aquifer called the Mount Simon, which is quite widely used in Minnesota and Wisconsin. It's not used much in Illinois because the water is pretty salty. There's kind of a thin freshwater lens on here, but if you start pumping that, you start getting the saline water pumped much. Just a couple of spots in the very northern part of Illinois. But you can see the complex geology, some of the shallow sand and gravel aquifers. There's a lot of, there's discontinuous and continuous sands, there's clays, there's silts. It's very complicated, and location. Depending on where you are, you could have some nice sand and gravel aquifers, and you could be 20 miles away and you won't have anything really to speak of until you get down to the bedrock. So one of the main sources of data that we need to use to do water supply planning is just how much water is actually used. And we rely on a program called the Illinois Water Inventory Program, or IWIP, and that's been in existence since the I think the mid-'80s or so. And so we collect data from all municipal users, all major industry and commercial users, and all power plants, for example. So basically, anybody who has a well of more than, what is it, 70, I can't remember now the actual term. Anyway, so it's a high-capacity well. Anybody using a high-capacity well. Just this past year, irrigation was added as being required to report. Before 2015, irrigators did not have to report. They had an exemption from it, but finally realized that they use a lot of water that they need to report it as well. So, so here, for example, is data from 2011, which is actually our latest report. We're a little bit behind because it takes a while to get all this data in. We're still kind of doing it the old-fashioned way. So you can see a lot of the uses up here in the Chicago region. Champaign County uses quite a bit for this is public. These are for public water supply withdrawals. Okay, and then this is just divided up by a township. The major user of water in Illinois is power generation, but most of this is considered non-consumptive use. So the water is removed from rivers, used for cooling, and then sent back into the river. There's an evaporative loss of something like 2 to 5%. This shows you the locations of where these major users are, and you can see they're all along major rivers: Mississippi, the Illinois, Rock River. So as part of water supply planning, we have to do these water demand projections, and these are very difficult to actually do. You have to consider things like population growth, cost of water, what kind of industries may be moving in or out of a region, and then you're pushing that out for 40, 50 years. So that's why they're straight lines, and obviously they're not going to be straight lines in real life. But this is the kind of thing that is being done in all the districts, and these have been done for all of the regions that are being studied. So this one is the results for the East Central Illinois region, showing the groundwater and the surface water projections. And so the projections, the BL baseline, that's the middle line right there. So that's kind of what's considered just kind of normal growth if kind of things continued the way they are going today. This is the kind of projections that we would predict. And then we have what's called a less resource intensive and a more resource intensive, so to kind of envelope what these predictions might be. So if we were really good at conservation, the LRI might be a better fit. If we're just wasting water, then the MRI might be more accurate. So you can see a growth from 20. We thought the numbers we used for this particular region was starting in 2005, going out to 2050. You can see kind of a rise there. And the same is true for northeastern Illinois and the Kaskaskia region. One of the interesting things we've found out is, at least in the northeastern Illinois, the less resource-intensive projections actually look better than the baseline predictions. So people are doing a better job of conserving water. There was also a recession that happened during that period that we obviously hadn't predicted for. So that's good news. Okay, so the demand is not as would have been expected from what was going on in 2005. So that means we're learning some things, I hope. And the new projections for the new regions are going out to 2060. So I mentioned 3 regions are complete. We have reports out for 2 of them. The Kaskaskia, I think, is just coming out. So this is the one you may have, those of you may have seen this for the Muhammad Aquifer and the surface reservoirs, East Central Illinois. And here's one for northeastern Illinois. These are available on our website if you're interested. So I'd maybe just go forward some of the results that came out of these studies and kind of give you a flavor for kind of the work that's being done for water supply planning. So here's East Central Illinois map. The green area is the famous Muhammad Aquifer. And then there's 4 cities use reservoirs as their primary source of drinking water: Decatur, Bloomington, Danville, Decatur, Bloomington, and Springfield. So Part of the work that's done is done by the Geological Survey. They're characterizing the geology, the subsurface geology. So, for example, here's the bedrock surface. You can see the Mahomet Valley in which the Mahomet Aquifer sits. And then they do also look at the quaternary deposits, the glacial deposits that sit on top. So where are these sands that we're going to be using? There's also sands above the Mahomet Aquifer that are used mainly for domestic use, but for some municipalities, they don't have to go down to the Mahomet Aquifer to get their water. And then from this information goes into groundwater flow models. So this is a kind of three-dimensional representation of the different layers that go into this model. And this is a model developed by George Roadcap at the Water Survey. And then we use the information we have from withdrawals from the Mahomet Aquifer system. So that IWIP program, everybody who has a high-capacity well, except for the irrigators, except they're reporting now, but in the historic data, we didn't have that information. We had to estimate it. So this is the amount of water that has been removed historically from the Mahomet Aquifer, our best estimate of it, going back to the late 70s. And you can see a general rise. It's kind of leveled off in the last few years. I don't have this out to 2015 yet, so I don't know if that's continued or not. You can see weather plays a role in 92 when we had those heavy rains, a lot of water. There was a lot less water used, mainly irrigation. So out in Mason County, which is the western part of the aquifer, they didn't have to irrigate so much, so the amount of water withdrawn was quite a bit less. In a drought in the late 80s, you can see there was a spike in the amount of water used. So it's definitely affected by the weather and the climate. And so then out of all this material that we can come up with, run the model and come up with some different ways to look at the water resources in the region. And this is a map that George Roadcap developed, just showing what are the impacts in different parts of the aquifer if we wanted to put some new high-capacity well fields, if we wanted to develop some new ethanol plants or whatever, or Bloomington wanted to go off of their surface water and go onto groundwater, how would that impact the Mahomet Aquifer? So in some areas, like out here in the west, in Mason County, where the aquifer actually comes to the surface, it's not confined, you could put hundreds of wells out there, and it really is not going to impact the quantity of water, at least, because the recharge is so rapid through that area. But other parts of the area, you could have some significant impacts on groundwater levels. So these are circled in red. You can see that we already have a big well field here for Champaign, Urbana, so putting more high-capacity wells out here, probably not a great idea. And then there's also these yellow areas represent possible connections of the aquifer with surface water. So if you pumped a lot of groundwater from the Mahomet Aquifer system, you may start depleting water that's discharging into the rivers and streams out there. So this is kind of the product that we're producing and giving to the RWSPCs. So surface water, some of the work that was done as part of this was done by Vern Knapp, looking at resiliency to drought. So an example is Lake Decatur. So here's some estimates that Vern did for the worst drought on record for that part of the state, which is 1930 to 1931. And so this is to estimate how much water is available, how much water would you need, would you run out during the worst drought on record at this point. And Vern's conclusion was Decatur was in trouble. And you may remember in 2012, we had a pretty serious drought. I don't know if you can see there's no water there, that's just mud. And it really affected Lake Decatur pretty seriously. And they were on emergency restrictions. Fortunately for them, Hurricane Isaac came through and filled it back up pretty quickly, actually. So the drought was bad, but it was very short-lived. So what would really be bad, though, is if we had like a 1 or 2 year drought, and then Lake Decatur would be actually, they'd need another source of water. And after that 2012 drought, they actually took some steps, putting in some new wells to supplement the water that's coming out of the lake. But this just shows you, some of the analysis that our surface water people do. Vern Knapp did, looking at, so this red was the 2012 drought, and you can see during the first 3 to 4 months of the drought, it was really about as bad drought as we've ever had in this part of the state. but you can see it ended very quickly compared to some of these other longer-term droughts. So as bad as it was nowhere near as bad as it could be if this hurricane hadn't come through and dumped 7 inches of rain in central Illinois. So that's the kind of stuff that surface water is able to produce as part of this water supply planning. And I'll just throw up one other slide for northeastern Illinois just to show some other work that's been done. So as you may or may not be aware, a lot of water in streams and rivers in Illinois starts as wastewater discharge. Okay, and this is especially true up in the Chicago region. So all that water is coming out of Lake Michigan, and these aquifers, and Fox River is passing through us, going to the wastewater treatment plants, and then it's all being dumped out into streams and canals and rivers up there. So the Fox River has quite a bit of wastewater discharge, and you can look, the dark blue line represents the unaltered flow before really people started messing around with the Fox River. And then the light blue line you can see is the present day condition. This is what's called the 10-year low flow, and going from north to south, from basically Algonquin down to Yorkville. And you can see there's quite a bit more flow than there would be if we were just under natural conditions. So what does that mean? Well, it's kind of a good news, bad news thing. You know, we're putting a lot of wastewater, but it's cleaned up, you know, but it's not pristine by any stretch of imagination. But you know, if you're in Aurora, you're getting when you're pumping water out of the Fox River, you're getting a lot of stuff coming from people in Elgin. Okay, it's been passed to the river and it's been mixed and everything, but you know, you just want to keep that in mind. But this is important to note though, and this is going to be especially true in arid and semi-arid areas, not in Illinois, but treated wastewater is a major source of water that we're going to have to be using. They're already using it in places like Orange County in California and other parts of the world. They're cleaning it up to a level where you can either inject it back into the subsurface, have it be filtered a little bit, and then pump it back out, or even just putting it into a river and then pumping it out downstream. So, I mean, it's not like 100 years ago when basically some of these rivers and streams and canals were just kind of open sewers. You know, the water has to meet certain water quality standards before it's released. But you know, if you're taking water out of a river, especially in northeastern Illinois, there's a good chance that a high percentage of that was wastewater at one point. Okay, so currently what's going on at the surveys as part of water supply planning? Well, we're trying to modernize this IWIP program. Even this past year, we were still sending out paper letters and getting paper responses, and then we have to call them and make sure they send them all in. Well, we're trying to put this all online, which should have been done years ago. We made a large, what we call a synoptic measurement of groundwater levels in the sandstone aquifers. I'll show you results of that in a minute. We're expanding our groundwater level monitoring network, especially in the new regions that we're studying. We're combining our regional groundwater models into a statewide model. We're modernizing our surface water accounting model, and then we're beginning scientific work in these new regions, the Middle Illinois River, the Kankakee, which is actually a sub-region. It was originally part of the northeastern Illinois, but it was kind of got left out because of budget constraints. So we're going back to work on that. And then northwestern Illinois, also known as the Rock River Basin. And then we're updating work that we've done in the previously studied regions, especially northeastern Illinois. So some of the data we've been looking at and collecting: water demand from these deep sandstone aquifers of the Cambrian Ordovician age, so they're very old. So the blue line represents the total in Illinois, and you can see that it really dropped into the 90s, and a lot of that had to do with the fact that Cook County and DuPage County, who used a lot of water from these deep sandstone aquifers, went off of the sandstone and went on to Lake Michigan water during that period. And so it's been fairly steady for most of Illinois. You can see it was at a minimum in the early 90s, and then it's been going up and leveled off a little bit in the early 2010s. This is for northeastern Illinois. So this is data from our IWIP program, just showing the groundwater withdrawals from these sandstone aquifers. And we got information from Wisconsin. We worked with the Wisconsin Geological Natural History Survey as part of this mass measurement, water levels that we did. And you can see the kind of the areas where the most pumping is done now in these sandstone aquifers. So this is the kind of the Joliet area down here. Rockford has a lot. I forget what city that is. Is that Madison? I'm not sure what that is. Anyway, certain areas, it's where you are is where the location is important. So in the middle Illinois River region, some of the work we're doing is evaluating public water systems at Pontiac and Streeter. These are get water from the Vermilion River, so they may be susceptible to drought, low flow conditions. There's also analysis of lock and dam operations on the Illinois River at Marseilles and Dresden Island, and then we've done some sampling of bedrock wells where we've been focusing on the St. Peter sandstone. I said I'd mention water quality at some point. So one of the things that we're doing is we've made a bunch of different kind of regional models for groundwater flow. So we had one for the Mahomet Aquifer. Then we did some county work up in McHenry County and DuPage County. Kane County and Kendall County. We developed models for each of those counties. Well, the models don't necessarily fit together all that well, and so we've gone to we made the decision that we want to combine all these models into a single model, so that when we update and expand the models, we just are working on one model, and we're not having to work on a bunch of different models. So it's not actually a statewide model. It's really the part of the state where the bedrock aquifers are important, so basically the top half of the state, northern half of the state. And it has to go outside the state as well into surrounding states, Wisconsin, Indiana, Michigan, Iowa, just because those units go all the way. I mean, these are units, widely ranging units that are used as aquifers in many other states as well. So we need to know the flow in those areas as well. So this is actually a pretty major effort that's undergoing. But the computing power is getting so much better. What's Moore's Law, right? So we're able to do this now that we couldn't do this a few years ago. I mentioned the synoptic measurement that we did. We sampled about 675 wells in Illinois and Wisconsin. This was the largest study that's been done since 1980. So we're basically measuring the level of water in all these wells, and then we're making a map. So here's the map that we made. And you might notice a red area. Okay, this is the cone of depression. All familiar with that term, around the city of Joliet. And pretty much the rest of the area is fine. This is in mean sea level. So there's a big cone there. And you also notice this black line through here. That's what's known as the Sandwich Fault Zone. And that's a geological structure that's kind of messing around with the flow down here. And we actually don't know a whole lot about what's going on south of the fault zone. We'd like to know more. But it's looks like it's preventing water from, when a well is pumped, it's trying to draw water from all directions. Well, if you're near the Sandwich Fault Zone, you can't really draw water from the south. It's blocked off, basically. So they're not getting as much water in these wells as they would hope. And as a result, the water levels have been dropping pretty precipitously. This was actually much, much worse than we anticipated. So this shows some hydrographs. So hydrograph just showing the water levels with time of some of these bedrock wells in northeastern Illinois. So Villa Park, here's Aurora, and here's the Joliet area. And this is the St. Peter's sandstone between the blue lines. And one of the problems is we're starting to dewater or desaturate the St. Peter's sandstone in some of these areas. And why is that a problem? Well, there's several reasons why that's a problem. So this just shows a little cartoon. Here we are pumping out of the sandstone aquifer. But if we start desaturating, so where we start emptying the pore spaces of water in the aquifer, one possibility is that shallow wells, domestic wells, tend to not go as deep as high production wells, so they're also just in the top part of the aquifer. Well, they could go dry. That's a problem. The wells tend to produce less water. You may have to be drilling more wells, excuse me. There could also be some chemical effects because you're exposing rocks that have not been exposed for millions of years, hundreds of millions of years, to oxygen. And oxygen can affect different species in the water, in the rocks. For example, up in Wisconsin, a dewatered aquifer started to produce higher levels of arsenic because there was sulfide minerals that had arsenic in them, and they were oxidizing, releasing arsenic into the water. We haven't seen that in Illinois, but that remains a possibility. And then, of course, if you continue to pump and come completely desaturated, then there's no water. You can't use it anymore. So this is something we really want to avoid doing. But we're already to the point where we're doing it. So if you look at this is some model results that we have done looking at what would happen to basically the Joliet region up to 2050 under various scenarios. So one would be, what if we just kept all the wells that were there, but we kept pumping them at the rate that they're pumping right now? So no new wells, no increased pumping. Well, even if we did that, these red and orange areas represent areas where partial desaturation or even complete desaturation would occur. And the yellow areas are at risk of being partially desaturated under pumping conditions. If we do the least resource intensive, if you remember those scenarios that I showed earlier, which would be our better scenario, but it implies some growth going forward. Quite a bit more areas would be desaturated, and if we used just our baseline, which looks like it's going to overestimate what the demand is, you'd have a much larger area. So this particular region in Will County and Kendall County is under some threat right now for their water resources. And we're actually we've had a meeting with the city of Joliet a few months ago, and we're going to meet with some industry groups up in the Joliet region next month to just explain what's going on and talk about alternative sources of water for that region. So I mean, that's bad news, but the good news is there are options. You know, Illinois has options because we do have quite a bit of water compared to like California and New Mexico, Arizona, places like that. So I mean, there are rivers that run through here. There is a big lake over here, you know, and I showed earlier that there is some capacity for using water from Lake Michigan. So there's a possibility that Joliet could tap into Lake Michigan water, and that might help solve their problems. It won't solve all the problems because there's a bunch of industries down here that have their own wells. So there's going to have to be some discussions and a lot of money spent to correct this problem. But really, this is an unsustainable situation that's going on up here right now. And I think the people up there realize that now, and they're starting to do some things to correct that. I think the battery died on this. Okay, so we've completed 3 regions. We're working on 2. We actually really haven't started too much on the northwestern Illinois, but we have plans to. And then there's the 5 other regions. Here they are: the Big Muddy, American Bottoms, Lower Illinois, Wabash, and Ohio, and Spindle, Lemoyne. So mainly the southern part of the state. We haven't gotten around to them yet, but they're on the list, and hopefully if funding continues through IDNR, we'll be able to do them over the next 5 to 10 years. And that's it. Turn it off.
Okay, we will take questions now.
I've heard that roughly a third of municipal water supply is used to irrigate lawns and other landscape. Do you know if that's true? Roughly a third.
I will say that up in northeastern Illinois, in those collar counties, on groundwater, there's a group called the Northwest Water Planning Alliance, and they have been pushing really hard to develop ordinances for different towns about lawn watering and no sod during certain times of year, things like that. So the actual water use for things like that has actually come down in recent years in places like Aurora and Elgin, and because they've been very proactive about trying to educate their citizens about wasting water, basically. And as a matter of fact, in 2012, when we had this drought, Aurora really, normally during a drought, the water spikes, the water use spikes. Well, Aurora didn't really see much of a spike in 2012, even though you saw how dry it was compared to like 2005, which was the previous drought. They saw a big spike in 2005, but in 2012 they did not see the big spike, and they attributed that a lot to the education effects and the ordinance that they had put out there.
I'm going to ask you why the water survey doesn't get out of the demand forecasting business and just focus on the supply, where I think your core competency lies. In these studies, they went out and hired economists to do demand forecasts, knowing that the data on which those forecasts demand is just pure crap, because there's no delineation between fixed costs and marginal costs of prices. So you cannot do decent things. Everybody's got different categories, whether it's commercial and industrial, where's the line between them? There's not even any good close looks at, so that's, I really think that I rather see the surveys focus on the public interest and the public trust. Like, their fish have a demand for water too, and trying to define some minimum flows on based on biology would be, ecology would be very helpful. And the result of what you're doing is that every dam builder company in Illinois looks at your statements about Springfield having an inadequate water supply because the demand forecast wouldn't have, we're projecting these really high demands when actual demand is decreasing significantly. So what happens is that the dam builders and the Chamber of Commerce panic. Oh my God, people aren't going to locate here because the Illinois State Water Survey, the gods in this business, have declared our water supply inadequate. And they go beat on the mayor's door and get the mayor to fund studies to build a new reservoir. And it's just nuts. It's not good science, and I think it's the surveys. If you'd focus more on sustainability and show us, you showed how the Joliet people are dewatering their aquifer, but you also showed how the Mahomet aquifer, or withdrawals in Champaign or somewhere, are steadily increasing over time. You declared Joliet unsustainable, and you didn't declare what we're doing unsustainable. So I'd rather see a little bit more scientific coherence in this, and maybe even a contraction of the areas where you do the research.
Yeah, well, we actually have had some long discussions about these water demand scenarios, and I will say we're not very happy with them. We have contracted out really with other people to do most of the work. We provide the data, the water demand, or the water use data and climate information like that. So we're not actually making these demand calculations. Those are being done by a professor down at Southern Illinois University. There are other groups that make these kind of calculations, and actually you make a good point, because we recently looked at a webinar. This was in the Southwest, so it's a bit different from here, but showing how demand forecasts are always wrong, and they're always wrong on the high side. And so this was for, I think he showed for maybe Albuquerque or Phoenix or someplace like that, showing how if you just stop the time, it was a kind of time versus demand. You had the actual data, and then you had all the projections that were done, maybe like 10 or 12 projections that were done over a 30-year period. And every projection went like this, then the demand went like that, and the new projection went like that, and the demand went like that, and the projection went like that. So they're always, projecting that there's going to be more water use than there is, and that's what we're finding with these original scenarios that were done. Like I mentioned, the LRI looks like it's more normal than the baseline would have been, but I mean, we're kind of stuck in a strange place here, because we need those numbers to run our models. We need scenarios to actually look at, and so we've talked about from now on, when we do these model runs, we're always going to have a scenario where there's no change. So we just look at what the pumping or the use is today, and that at least gives us kind of a flat number. Demand can drop, though. It can go below what it is. But, again, you're right. We're not economists. We're not planners. So we do want to focus on the science, but we have to get those numbers from somewhere, and we'd prefer to get them from somewhere else, actually. You're talking about the actual users of the data? Oh. Well, are you talking about pricing? Yeah. Okay. I mean, we mainly focus on the actual water use. We're not looking at the costs. So, I mean, you're right. We probably should, but somebody has to do it, and we've got to have those numbers from somewhere. So, I'd be happy to let them do it.
Are there any questions from online? Okay. We'll take another one from here.
Yeah, I was interested in what you're finding is the biggest threat to water quality. I mean, if you can get the water, fine, but if the quality is degraded due to, for example, rivers, due to wastewater discharge, I don't know, pharmaceuticals, phosphonates, and then also in the aquifers, if there's any, during recharge, is there becoming threats to those too? What are you measuring in that regard, and what are you finding?
I should probably defer the surface water question to Mike Nemicheski back at the back of the room. He's an expert on that. But groundwater, I'll just quickly talk about that. So actually, probably the major, at least toxic chemical in groundwater in Illinois is arsenic. And that's a natural contaminant. Radium is also a major one in some of the bedrock aquifers. So there's nothing that we're doing that's actually causing that. That's not pollution by humans. That's just a natural process that's causing that. So from that point of view, those are probably the major ones. Probably the two major human sources of contamination to groundwater are nitrate, which is common in many agricultural settings, and then up in the Chicago region is road salt runoff. So water is being salinized in both groundwater and surface water due to the heavy use of road de-icing salts. And while that's not a human contaminant, it's not toxic, it's not regulated as a drinking water standard, it's not good if it gets out into the surface water. It's bad for certain aquatic organisms. And then also, if it gets to a certain level, it's bad to taste, and we want to treat it so that we don't have as much chloride. So these things are expensive if we have to deal with them. So unfortunately, there's not a great solution because there's a lot of snow in Chicago and there's a lot of roads. A lot of people want to get to work. Salt is very cheap to use, very effective, but it ends up in our water resources. So I would say that's one of our main human contaminants in Illinois. As far as surface water, again, the nitrogen species, a lot of agricultural things. Right. One of the newer ones is pharmaceuticals and personal care products. If you come in 2 weeks, I think, Wei, you're going to be giving a talk on that, right? So that's coming out of like sewage for the most part, also coming out of confined animal feeding operations. So does that answer your question? So we try to measure as much as we can. Some of these things are very expensive to measure, unfortunately. The PPCPs, for example, that's a pretty intensive analysis that has to be done. So we can't routinely do a lot of those things just because we don't have the money.
It's great to provide this sort of information, and it's valuable to kind of know what's going on to collect this. But it seems like, from a sustainability standpoint, if we're going to help improve whatever situations may be coming up down the road, there's going to be an educational component, and I think a lot of us here are educators. What are some of the core issues that you think people are going to need to be raising awareness about in a more public way, and do you have any thoughts about how that might happen?
Well, one of the things that we're trying to do now is, so I mentioned this study we did of the water levels in the bedrock aquifers, and we have a big report coming out. Well, no one really going to read that except people who are intimately involved in the program. But we're developing, I think, 3 short 2 to 4 page public documents discussing the implications of the results of those studies. So that's one thing that we're trying to do. I mean, we're trying to get out to talk to the planners. I mentioned we're going to be talking to these industry groups up in Joliet, just to get the word out. What is the significance of this, and what should they be thinking about as they're moving forward? As far as the more public education, I mean, we're always happy to come out to talk to people. If you have, a venue that you'd want us to come to, just contact us, and we'll see if we can come out and help you. I mean, we've talked to schools. Mike and I have gone to a different high school to talk about stuff. We don't probably really have a real organized plan for that, though. But it's something that's very important that we should be doing more of, I think. I agree with you. If you have ideas, let me know. Well, basic conservation, I think, would be the place to start. Don't run your tap while you're brushing your teeth. Don't take 20-minute showers. All sorts of, things like that. You don't need to water your lawn. Don't put sod down in July. That makes no sense because you're going to water like crazy. So, just some basic things like that. Nancy, do you have some things?
I was just going to mention we have our 1 billion gallon water challenge here at ISTC, where we're working with water conservation with industry as well as trying to get the word out to general public. So if you look on our website, we have some tips there, and it links to other sites that have like a quick page for people to save water, and that's what we're trying to promote with that.
And every other year, the Institute has what they call an expo, and it's mainly for kids, grade school kids, some high school kids I think show up too. We bring out our groundwater flow model just to show how easy it is to contaminate groundwater, things like that. So. Yeah. Yeah, that's the first question I ask kids when they come to our display. Well, do you know where your water comes from? And a few know because they've had the unit on the Mohammed Aquifer, but most of them have no idea. Turn on the tap, there it is. I think you're right. I think you're absolutely right.
Yeah, we'll take one more question.
Yeah, Walt, how hard would it be for Chicago to send their water back into Lake Michigan as opposed to letting it go down the Mississippi River?
That's an interesting question, actually. And they actually started talking about it, and the main reason, though, is not that question, but is the Asian carp. Because the Asian carp have gotten all the way up into the Des Plaines, or the canal system up there. They've got these, actually, I'm not sure how far it has gotten. But anyway, they've got these barriers, electric barriers, and there's been a lot of pressure from other states to, stop the flow, stop Chicago taking water up because the Asian carp is going to get hit. So that would solve a lot of problems. The cost would be just astronomical, though, I would think. I have no idea how much it would cost to reverse flow of rivers and send the sewage. The Stickney is one of the it may be the largest wastewater treatment plant in the world, and that's, I don't know, 10 miles away from Lake Michigan or something like that, and, going uphill. I know you'd have to do a major engineering work, but people are talking about it. No, I don't know. I'm not an engineer.